The James Webb Space Telescope, JWST, serves as the premier international instrument for exploring the cosmos. Its primary objective is to uncover the secrets of our solar neighborhood, distant exoplanets orbiting other suns, and the intricate formations composing the universe, all intended to enhance our understanding of humanity's place within the vast expanse of space. In a pioneering endeavor, researchers recently directed the JWST toward a star approximately 120 light-years from Earth. This investigation uncovered persuasive evidence of carbon-based substances within the atmosphere of a planet potentially encircled by vast oceans, an extraordinary milestone for scientists worldwide. But how was this remarkable discovery achieved? This advancement in science provides a captivating glimpse at a planet outside our solar system that is dramatically unlike any we know, prompting essential inquiries into the likelihood of life-supporting worlds beyond our own. NASA's James Webb Space Telescope has recently delivered a revolutionary insight about the exoplanet K2-18b, a distant celestial body possessing a mass 8.6 times greater than that of Earth. What makes this revelation particularly fascinating is the identification of carbon-related gases, such as methane and carbon dioxide, in its atmospheric layers. This finding reinforces earlier hypotheses suggesting that K2-18b may have conditions conducive to life. The planet seems to feature a hydrogen-rich atmosphere and perhaps a surface cloaked in water. The first assessment of its atmospheric composition within a region considered capable of sustaining life was initially performed using NASA's Hubble Space Telescope, significantly broadening our comprehension of the star system. K2-18b lies around 120 light-years away in the Leo constellation and orbits a relatively cool red dwarf star called K2-18. Residing in the habitable zone of its stellar host, K2-18b falls into a class of planets larger than Earth but smaller than Neptune, often labeled sub-Neptunes, which are absent in our solar system. The idea that K2-18b beholds plentiful carbon compounds and maintains a hydrogen-dominant atmosphere excites scientists globally. Many believe these types of planets might rank among the most likely candidates in the ongoing quest to discover extraterrestrial life. The detection of methane and carbon dioxide, and significantly, the lack of ammonia, supports the theory that this world could shelter an ocean beneath its dense hydrogen skies. Preliminary evidence even alludes to the potential presence of dimethyl sulfide, a compound tied to biological activity on Earth, mostly produced by microscopic marine organisms. Nonetheless, its confirmation on K2-18b remains ambiguous and necessitates additional analysis. Ongoing monitoring with JWST's state-of-the-art instruments aims to determine whether dimethyl sulfide exists in measurable levels within the planet's atmosphere. According to a scholar at the University of Cambridge, although K2-18b resides in a zone where liquid water might persist and host carbon-bearing gases, that alone doesn't definitively prove the planet supports life, especially since its diameter is 2.6 times that of Earth's. It is probably enshrouded in a thick, high-pressure icy layer resembling Neptune's, overlaid by a thinner hydrogen envelope and potentially home to surface oceans. Even if such water bodies are present, they may be inhospitable due to extreme pressure or unstable chemical settings, rendering them unfit for life as we know it. Still, scientists have now captured the most precise atmospheric data ever collected from a possibly life-friendly sub-Neptune, enabling them to distinguish various components in the air. A scientist from Cardiff University noted that they overcame observational hurdles by analyzing how starlight passed through the planet's atmosphere during transits. K2-18b is a transiting exoplanet, meaning it briefly blocks part of its star's light as it moves in front of it. This is how NASA's K2 mission first discovered it. During these events, a portion of the starlight passes through the atmospheric layers before reaching Earth. Space-based observatories like JWST can then examine the resulting light spectrum to identify which elements or compounds are present. The scientific team intends to conduct further investigations using JWST's mid-infrared sensors to validate the existence of specific molecules and gain a clearer understanding of K2-18b's environmental conditions. Their broader goal is to hunt for signs of life on planets that could potentially support living systems, a pursuit that may transform how we see our role in the universe. Beyond this particular case, JWST has facilitated numerous other astonishing findings. Astronomers utilizing the telescope have identified intricate organic substances resembling industrial haze or soot in a faraway galaxy. This marks the earliest known detection of such chemicals in the cosmos. The discovery is both awe-inspiring and somewhat unsettling. These results are reshaping our core scientific assumptions about the composition of the universe. The substances, aromatic hydrocarbons, were located in a galaxy that originated when the cosmos was just about 1/10 of its current age. These carbon-laden molecules, which on Earth are commonly present in petroleum and coal and contribute to air pollution, are large and structurally complex, made up of dozens or even hundreds of atoms. What makes this revelation particularly surprising is that such elaborate compounds appeared so early in the universe's history, challenging long-standing theoretical models. To put it into perspective, the light observed from that distant galaxy began traveling nearly 1.5 billion years after the Big Bang. Since the universe is approximately 13.8 billion years old, this discovery traces back to a very ancient epoch. Even more notably, JWST enabled this discovery and is expected to help uncover similar molecular evidence in even older galaxies, perhaps just 1 billion years after the universe's inception. If we could peer further into the early cosmos, might we find more of these molecules closer to the origin of time? This possibility presents important questions about today's prevailing theories of cosmic evolution. Previously, scientists could only speculate that such materials were present in the early universe. Now, thanks to JWST's unmatched precision, we can pinpoint where these molecules reside. Additionally, the uneven spread of these compounds in the distant galaxy SP41847 adds another layer of mystery. What's especially intriguing is that this galaxy had already developed to a mass comparable to the Milky Way and had synthesized similar amounts of carbon and oxygen, despite existing when the universe was only 1/10 as old as it is now. As human knowledge continues to expand, driven by curiosity and intellect, we are consistently reminded of the sheer scale and complexity of the cosmos. Every scientific advancement draws us nearer to decoding the cosmic enigmas that envelop us. As the world's space science capabilities progress, it's only a matter of time before even more mysteries of the universe are uncovered, revealing deeper truths about our purpose and position in the cosmos. As our astronomical knowledge grows, the James Webb Space Telescope persistently delivers findings that reshape our perspective. Its contributions are redefining how we interpret remote planets and galaxies, pushing the boundaries of what is scientifically possible. This extraordinary telescope empowers us to look deeper into space than ever before, revealing phenomena that previous generations of astronomers were unable to detect. The identification of advanced organic matter in primordial galaxies is a compelling example of JST's crucial role in clarifying how the early universe was formed. One of the most exciting implications of these discoveries is the notion that life, or at least its essential components, could be far more prevalent than once thought. The recognition of carbon-based materials on planets such as K2-18b opens up fresh possibilities for locating biosignatures on worlds that might resemble Earth. Compounds like methane and carbon dioxide are closely linked to biological functions on our planet. Although detecting them on distant planets doesn't definitively confirm alien life, it does strongly encourage further exploration. Forthcoming missions will place even greater focus on evaluating the likelihood of life beyond Earth. JWST's capability to analyze planetary atmospheres with exceptional accuracy signifies a significant leap forward. It allows researchers not just to detect basic gases, but also to identify more nuanced chemical traces that may be linked to biological systems. This degree of analytical detail is crucial for determining whether remote planets can genuinely sustain living organisms. As our insight deepens, so does our ability to identify even the subtlest clues of life, whether in the form of trace elements, organic particles, or other potential biological byproducts. In addition to its exploration of exoplanets, JWST is offering critical revelations about how galaxies form and evolve. By studying ancient galaxies, scientists can trace trends in star formation, element distribution, and gravitational behavior that influence stellar development over billions of years. This understanding is key to decoding the history of our own galaxy, the Milky Way. The detection of aromatic hydrocarbons in a galaxy from the early universe showcases how far we've come in revealing the origins of cosmic architecture. As humanity extends its reach into space, every new discovery brings us closer to solving some of the most profound questions ever asked. Are we alone in the cosmos? How did life begin? What is the destiny of the universe? These timeless questions have stirred the minds of scientists, philosophers, and dreamers for ages. Now, equipped with tools like the James Webb Space Telescope, we are more capable than ever of pursuing the answers. Every new insight expands our vision and brings us a step closer to unveiling the truths concealed among the stars.